Hello everyone, I am Ms. Sushma, working as Assistant Professor in EC Department, IARE. In this lecture, we are going to discuss about LTI system, impulse response and convolution of discrete signals. So first of all, what is LTI system? LTI, L is linear time invariant systems are systems that are both linear and time invariant systems. So it should satisfy both linearity property as well as time invariant property. So in LTI system, the input it is x of n and it is denoted by y of n. This output, this LTI system should satisfy the linearity property as well as time invariant property. If it satisfies these two properties, then the system is called LTI system. So linearity property is nothing but it should satisfy the superposition theorem. It should satisfy the superposition theorem as well as time invariant property. So here LTI systems are used to predict long-term behavior in a system. LTI systems are superior to simple state machines for representation because they have more memory. So here it should satisfy the LTI system has the satisfy the superposition theorem, that is weighted sum of the input response should be equal to the weighted individual responses of the output. That is nothing but transformation of A1 x1 of n plus A2 x2 of n is equal to individual responses of the output, that is nothing but A1 y1 of n plus A2 y2 of n. This is the superposition theorem. And time invariant property is nothing but the output should not depend on the what time the input is applied to the system. Okay. So here y of n comma k, the delayed output response is equal to the delayed output response. Then the system is a time invariant system. So LTI system should satisfy these two properties. Then the system is linear time invariant system. So for example, I am considering here y of t is equal c into x of t. So it satisfies the superposition theorem. Superposition theorem. So this system is called linear system. As well as this system satisfy the y of n comma k is equal c into, that is y of n minus k. Then it is satisfying the both linearity as well as time invariant properties. Then the system is time invariant, linear time invariant system. But some systems, suppose I am taking y of n is equal to x cube of n. Here the system will satisfy the only time invariant property. The system will satisfy only time invariant system. It is not a linear system, it is a non-linear system. So this system is not a LTI system. Okay. So LTI system should satisfy the two properties, time invariant system properties as well as non-linear system properties. So first of all, we will know the representation of an arbitrary sequence, how x of n will be represented in terms of arbitrary sequence. So here I am taking the x of n as input to the system. So here the system, I am taking system. The input of the system is denoted by x of n. The output is denoted by y of n. So here a sample, any system can be represented in terms of the delayed and scaled impulse responses of the del of n. So any input x of n can be represented in terms of delayed and scaled impulse sequence of del of n. So how we can be represented x of n in terms of impulse sequences? So here, for example, I am taking x of 0. So in x of n, I want to get x of 0th sample. This can be obtained by multiplying the sequence x of 0 by the del of n. So x of 0 is multiplied by the del of n, that is impulse signal, then you will get the 0th sample of your x of n, that is x of 0 for n is equal to 0 and 0 for n is equal n not equal to 0. So now what is impulse signal here? Impulse signal is 1 for n is equal to 0, 1 for n is equal to 0, 0 otherwise. If you want x of 0, we are multiplying with the del of n, you will get the x of 0 for n is equal to 0 and 0 otherwise. So like that, similarly, if we want to get the x of minus 1 sample at the output, we should multiply the x of minus 1 sample with the del of n plus 1. So you will get the x of minus 1 for n is equal minus 1 and 0 for n is equal otherwise. So here del of n plus 1 can be defined as 1 for n is equal minus 1 and 0 otherwise. So if we multiply this x del of n plus 1 with the x of minus 1, you will get the x of minus 1 sample will be multiplied by the del of n plus 1 sample, that is 1, and you will get the x of minus 1 yet n is equal minus 1, 0 otherwise. So every individual sample of the input signal we can denote it by the impulse signal. So like that, x of minus 2, if you want to get the x of minus 2 sample at the output, we should multiply the x of minus 2 with the del of n plus 2. Then you will get the x of minus 2 for n is equal minus 2 and 0 for n not equal to minus 2. So like that, if we represent this every individual sample of the input signal, that is x of n by del of n into del of n minus 1 is equal to x of 1 into x of 1 for n is equal 1, 0 otherwise. X of 2 del of n minus 2 is equal to x of 2 for n is equal to 0 otherwise. Suppose I want to get the sample x of 3 at the output, I should multiply the x of 3 by del of n minus 3. Then the particular sample will be coming to the output. So for n is equal 3, 0 otherwise. So like that, every individual sample can be represented by the weighted or scaled of the impulse signal. So for example, I am taking x of n one sample sequence, x of n sequence, n is equal 0, where I have the amplitude 1, for 1 3, yet n is equal to 2. For n is equal minus 1, the amplitude is 3, for n is equal minus 2, the amplitude is 2. So if we multiply the x of n with the del of n, so del of n is 1 for n is equal 0, otherwise the samples are 0 for impulse signal. So here, if we multiply x of n with the del of n, the n is equal 0th sample will come into the output. So that 1 into the amplitudes will be multiplied here, 1 into 1. So the x n is equal 0, we will get the sample, that is x of 0 into del of n. If you want to get the x of n into del of n minus 1, so here the del of n minus 1 be represented by the del of n minus 1 be represented by the, for n is equal 1, the amplitude is 1, then it is del of n minus 1, otherwise it is 0, then that is del of n minus 1. This signal will be multiplied with the x of n, then you will get the x of 1 into del of n minus 1. So that is the sample value n is equal 1 of the input is 3. So 3 into the del of n minus 1 is, for n is equal 1, it is 1. So 1 into 3, 3. So the 3 will get n is equal 1. So that is x of 1 into del of n minus 1. So if you want to get the second sample, so second sample of your x of n, so n is equal 2 samples. So we have to multiply it with the x of n with the del of n minus 2. then you will get the n is equal to sample of your x of n. So here every sample, if you want to multiply the x of minus 1 with the del of n plus 1, we will get the minus 1 sample of n is equal minus 1 sample of the x of n. So like that every individual signal can be represented with the particular delayed version of multiplication, scaled and multiplication of the delayed impulse signal. So like that, if we generally we can write this x of n for minus infinity to infinity. So x of n is equal, so minus infinity to infinity. So x of minus 3 into del of n plus 3 plus x of minus 2 into del of n plus 2 plus x of minus 1 into del of n plus 1, x of 0 into del of n plus x of 1 into del of n minus 1, x of 2 into del of n minus 2, x of 3 into del of n minus 3. That is nothing but x of n is the combination of the all input samples of x of n. So here you will get the x of minus 3 sample, here you will get the x of minus 2 sample, here you will get the x of minus 1 sample, here you will get the x of 0, x of 1, x of 2 and x of 3. Like that, it is the summation of individual particular sample of the input with the impulse delayed or advanced version of the impulse signal. So this can be written as, here x of n we can written as, for k is equal minus infinity to infinity, x of k into del of n minus k. So for example, I am substituting here k is equal minus 3. So I will get the k is, from k is equal minus 3 to 3. So this I can write x of minus 3 into del of n minus 3 plus, for k is equal minus 2, it is x of minus 2 into del of minus of minus, it is plus. So n plus 2 plus x of minus 1 del of n plus 1 plus x of 0 into del of n. Like that we can expand this equation. Okay. So here del of n minus k is unity for n is equal 1 and 0 for all other terms. So this is the formula for any input signal. We can represent it as in the arbitrary sequence with the impulse, advanced or delayed version of the impulse signal. For example, I am taking the sequence x of n is equal 1, 0, 2, 1. So this arrow mark indicates the 0th sample of that sequence. If we want to represent this x of n in terms of arbitrary sequence, so this is the 0th sample, minus 1 sample, 1 and second sample. So this we can write as x of minus 1 into del of n plus 1 plus x of 0 into del of n plus x of 1 into del of n minus 1 plus x of 2 into del of n minus 2. So substitute values of x of minus 1, x of 0, x of 1 and x of 2. Say x of minus 1, the amplitude is 1. So 1 into del of n plus 1 is del of n plus 1. X of 0 value is 0. So 0 into del of 1, 0. Plus x of 1 is 2 here. 2 into del of n minus 1. Plus x of 2 is 1 into del of n minus 2. So this is del of n plus 1 plus 2 into del of n minus 1 plus del of n minus 2. So any arbitrary sequence we can represent in terms of delayed or advanced of impulse signals. So here what is impulse response? So any system is LTI system is characterized by the impulse response. So what is the impulse response? If the input to the system, if you are taking any LTI system, okay, here I am taking any LTI system, I am taking the x of n is input, I am getting the response as y of n. So the input of the system is impulse signal, then the response of the system will become impulse response. Okay, this y of n will be denoted as transform of x of n. Here h of n we can write as transform of, what is input signal is here? Del of n. So here if the input of the system is impulse signal, then the response of that system is denoted as impulse response. So here the impulse response will be denoted by h of n. So that is will be written as h of n is called transform of del of n. So impulse response is especially important property of LTI system, linear time invariant system. So impulse response tells us how the system will behave for inputs at all frequencies. So here the input is del of n for the LTI system and we are going to get the response as h of n. So convolution sum. So here the convolution is a mathematical way of combining two signals to form a third signal. So it is the single most important technique in digital signal processing. Here, this is one of the important property of LTI system. Here, we will get LTI system has an impulse response h of n and input is x of n. Then the response of the system will be denoted as convolution, convolved of these two input signals, that is x of n is convoluted with the h of n, the impulse response of the particular LTI system, and x of n is the input of the particular LTI system. So here the convolution sum is denoted by the star here, this symbol. Okay, so here convolution is nothing but the what is the effect of the one signal by the another signal. It will produce the third signal, that is convolution sum. So x of n is input and y of n is output and h of n is the impulse response of LTI system, linear time invariant system. So x of n convolved with h of n, you will get the response of the LTI system is y of n. So y of n is denoted by x of n star h of n. So for example, high pass filter I am taking here. This high pass filter has the input signal and it is convolved with the particular filter impulse response and it will produce the response as output signal. This symbol indicates the convolution of input signal and impulse response of an LTI system produce the response of the LTI system. So here we know the h of n is impulse response of the LTI system, that is the if the input of the system LTI system response is h of n and the input is x of n, we have to find out the response of y of n. So here h of n we can denote if the input of the system is del of n, we will get the response impulse response, that is denoted by the h of n. So here h of n is equals transform of del of n. Okay, so that is the first equation. But we have to find what is our aim. We have to find out the response of the LTI system, that is y of n. So y of n is denoted by transform of x of n. So here this x of n we can represent it in terms of arbitrary sequence, that is in terms of impulse responses, that is x of k into del of n minus k. So any input signal can be represented as arbitrary sequences by k is equal minus infinity to infinity, k is equal minus infinity to infinity, x of k del of n minus k. This is equation 2. So this we can write as y of n is equal k is equal minus infinity to infinity, x of k. This transform of del of n minus k. Transform of del of n minus k. This is equation 3. So here we are taking LTI system which should satisfy the linearity property as well as time invariant property. What is time invariant property here? Time invariant property, the response if the input is delayed by the k units, that is transform of x of n minus k. If the input is delayed by the k units, then the response we are going to get is y of n comma k. That is should be equal to the output response, that is output is delayed by the k units. So if these two are equal, then the system is time invariant system. So here we are considering the impulse response. The impulse response is nothing but here t del of n minus k. Del of n is input to the system. Impulse response, I am getting h of n is impulse response, input is del of n. If it is delayed by the k units, then the response will be denoted by h of n comma k. If the input is delayed by the k units, then the response is of that system is denoted by impulse response is denoted by h of n comma k. So here h of n comma k can be represented as transform of del of n minus k. So that is the fourth equation. So it is the linear, it is a time invariant system. So it should satisfy the property of h of n comma k is equal h of n minus k. So we can write this equation transform of del of n minus k, we can write that as h of n minus k. We can replace this h of n comma k by h of n minus k. So finally we will get the y of n is equal sigma k is equal minus infinity to infinity h of k into del of n minus k. This is the formula for the convolution, and we can write this as sigma k is equal minus infinity to infinity h of k. We can write like this also, h of n minus k also. Okay. So for any linear time invariant system, if the input sequence x of n and the impulse response of the particular LTI system is denoted by the h of n, then the convolution is denoted by the y of n is equal sigma k is equal minus infinity to infinity x of k into h of n minus k. So that is sigma k is equal minus infinity h of k x of n minus k, that is x of n convolve with the h of n. This is the formula for convolution sum of an LTI system. Okay, here the properties, commutative property is x of n star h of n is equal h of n star x of n, and associative law is x of n star h of n is convolved with the h2 of n, then you will get the same result as first individual responses of the LTI system convolution with the inputs x of n, and distributive law is x of n star h of n plus h2 of n, we can write as x of n star h1 of n plus x of n star h2 of n. And if we cascade two impulse responses of LTI system h1 of n and h2 of n, and this is y of n, then we can write this as h1 of n star h2 of n. These two impulse responses will be multiplied, and we will get the response. And if we add these two LTI impulse responses, this we will get h1 of n plus h2 of n. If we cascade, then two impulse responses will be denoted as h1 of n into h2 of n. If we add these two responses, h1 of n plus h2 of n. So once again I will repeat this, how we will write this via convolution sum derivation. Y of n is equal sigma k is equal minus infinity to infinity transform of your input signal. So input signal can be represented as arbitrary sequence weighted as scaled impulse responses. So here we can write this as k is equal minus infinity to infinity x of k transform of del of n minus k. So here transform of del of n minus k is nothing but delayed impulse response, that will be denoted by h of n comma k. So here it is a LTI system. It should satisfy the time invariant property. time invariant property, that is h of delayed input response is equal to the delayed output response. So substitute this we can write here from the above equation, sigma k is equal minus infinity to infinity x of k. This del of n minus k we can write that as delayed impulse response h of n comma k. So substitute 2 in equation, substitute 3 in equation 2, you will get y of n is equal sigma k is equal minus infinity to infinity x of k. We can write this h of n comma k, delayed input impulse response is equal to the delayed output response h of n minus k. So this is the final output response of the LTI system. We can write this as sigma k square minus infinity and infinity h of k into x of n minus k. We can write like this. So this is the convolution of x of n star h of n. So we will see the two problems and convolution sum, then we will know the how to implement the formula for convolution sum. So here determine the response of the system characterized response h of n is equal 1 by 3 whole power n u of n to the input signal x of n is equal 3 power n u of n. So here both the sequences we should represent that in terms of k index. So here h of k is equal 1 by 3 whole power k u of k and x of k is equal 3 power k u of k. So the what is formula of the response if the system LTI system has the impulse response h of n and input signal h of n, we have to find out the response y of n here. So the response of the system we can write this as sigma k is equal minus infinity to infinity x of k into h of n minus k. So here sigma k is equal, it is in terms of unit step signal. We can write the limit from 0 to n because it is a causal system. You have unit step signal here. So here x of k we can write as 3 power k u of k into h of n minus k we can write as 1 by 3 whole power k u of n minus k u of n minus k. So here we can write this as sigma is equal 0 to n 3 power k u of k, it is 1 and 1 by 3 whole power n minus k. So here sigma k is equal 0 to n 3 power k 1 by 3 whole power n into 1 by 3 whole power minus k. So this we can write as here y of n is equal sigma k is equal 0 to n 1 by 3 whole power n 3 power k into 3 power k, that is 1 by 3 whole power n sigma k is equal 0 to n 3 power 2k. So here the formula for sigma k is equal 0 to n a power n is if a is greater than 1, then it is 1 minus a power n by 1 minus a. So here this will be write as 1 by 3 whole power n. It is 1 minus 3 square whole power n by 1 minus 3 square. So this is we can write as 1 by 3 whole power n. This is 9 power n plus 1 minus 1 by 9 minus 1. This is 1 by 3 whole power n into 9 power n plus 1 minus 1 by 8. This is the response for the given h of n and x of n. So here another find the convolution of x of n is equal cos n pi u of n and h of n is equal 1 by 2 whole power u of n. See here, the response x of n will be, convolution will be denoted by x of n star h of n. That is, the formula is k is equal minus infinity to infinity x of k into h of n minus k. Here it is in terms of unit step signal, so the limits will become right as it is a causal signal. K is equal 0 to n. Here x of k is here cos n pi u of n. So cos this we can write as cos n pi, we can write as minus 1 whole power n u of n, that is minus 1 whole power k u of k into, here h of n minus k is 1 by 2 whole power n minus k into u of n minus k. So this we can write as sigma k is equal 0 to n minus 1 whole power k, u of k is 1 per 0 to n, so minus 1 whole power k into 1 by 2 whole power n minus k. And here the sigma k is equal 0 to n minus 1 whole power k 1 by 2 whole power n. We can split these two terms, this minus k. So here the limit depends on k. We can bring over the 1 by 2 whole power n. Sigma k is equal 0 to n. We can write this as minus 1 whole power k into 1 by 2 whole power minus k. This we can write as y of n is equal 1 by 2 whole power n and sigma k is equal 0 to n. This we can write as minus 1 whole power k into 2 power k. So here 1 by 2 whole power n, sigma k is equal 0 to n. This minus 1 whole power k into 2 power k, we can write this as minus 2 whole power k. This is a formula. Here is 1 by 2 whole power n, 1 minus of minus 2, n plus 1 by 1 minus of minus 2. So after simplifying we will get here, this is 1 by 3, 1 by 2 whole power n u of n plus 2 by 3 minus 1 whole power n u of n. We will get this one. So we have to find out the convolution sum of two signals by applying the formula y of n is equal sigma k is equal minus infinity to infinity x of k into h of n minus k. We can write this as otherwise k is equal minus infinity to infinity h of k into x of n minus k. So here convolution sum we can do by using two types: linear convolution and circular convolution. Convolution of an LTA, any LTA system we can do by linear convolution, and the convolution, if the sequence is periodic signal, if x of n is a periodic sequence, then the convolution we can do by the circular convolution. Here we will discuss these two types, linear convolution and circular convolution, in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.